Welcome everyone. In this video, we're going to discuss line integrals over vector fields. So earlier we talked about how to do line integrals over for a scalar functions. Now we're going to look at line integrals over a vector field. So the formula that you want to remember is if you're having a line integral along a curve C of a field f dot dr, this is pretty much the same as writing as the integral from a to b of the field evaluated at r of t, which is your parameterized curve C. And we're going to dot that with the derivative of r prime of t, and then we're going to integrate respect to t. So that's the formula we want to remember. So let's go ahead and find each component. So first we're going to parameterize our curve C. If for this problem, it's the part of the parabola y equals x squared plus 1 from 0, 1 to 2, 5. And this is our field. So let's go ahead and parameterize curve C. Let's take a look at a picture first. So if you were to draw that curve over this field, so I'm not going to draw the field for you, but imagine it is in a vector field. So y equals x squared plus 1. We all know that's a parabola. So it's going to have a y-intercept at 1. And let's just draw this side of it. Now, of course, there's this side too, which we're not going to draw. So we're only going to integrate along this curve from 0, 1, going this direction to the point 2, 5. Let's suppose this is 2, 5. So this is our path of integration. That's curve C. And let's label this. This is 0, 1. So we're going to parameterize curve. We're going to represent that as a vector valued function, r of t. So since x is free, y is equal to x squared plus 1, we're going to pick our x component to be t. Then y would be t squared plus 1. So simply I plug that in right here, and I got an expression for y in terms of t. So this is our r of t. And t is going to go from the starting point of the curve right here, which is from x equals 0. So t will also go from 0 all the way to 2. So t will go from 0 to 2. All right, so now let's go ahead and find r prime of t. So taking the derivative component-wise, so this is t. So derivative of t respect to t, that's 1. And then derivative of t squared plus 1, that's going to be 2t. And now we're going to evaluate our field at r of t. So that means using this field right here, we're going to substitute this is for x and this is for y. So the field is x times y. So we're going to sub in x is t, y is t squared plus 1. And for the second component, that's just 2. There's nothing to substitute. And now we're going to go ahead and do the dot product. So we have f at r of t. We're going to dot that with r prime of t. So let's do that. So we have, so before that, let's go ahead and distribute this out. So this is equal to, in simplified form, t to the third plus t comma 2. And now we can do the dot product. So we have t cubed plus t comma 2. And we're going to dot that with r prime, which is this one right here. So that's going to be 1 comma 2t. So this will give us, so for by dot product, we multiply this times that and add to the product of this on that. So this is going to be t cubed plus t plus 4t. And then we can combine some like terms like these. So this can be written as t to the third plus 5t. So that is what our replacement will be in the integrand for f dot dr. All right, so that means our line integral along the curve C of f dot dr, this is equal to the integral from a to b of f of r of t dotted with r prime of t dt. And we already know what's in the integrand, so we know this is what we're going to replace right here in place of this. And our limit of integrations are going to be right here, the t values from 0 to 2. So this will be equal to the integral from 0 to 2 of t to the third plus 5t dt. And now this integral is super easy to work it out. So we have the integral of t cubed, that's going to be t to the fourth over 4, plus integral of 5t respect to t, that's 5t squared over 2. And now we can evaluate this from 0 to 2. So plug in the upper limit of integration, we have 2 to the fourth over 4 plus 5 over 2 times 2 squared. And then if you plug in the lower limit of integration, you'll get 0. So this will simplify to, so 2 to the fourth, that's going to be 16 divided by 4, that's 4, plus 2 squared, that's 4, divided by 2, that's 2, 5 times 2, that's 10. So this is going to be 14. So the value of this line integral is 14. All right, I hope this makes sense. Take care.